Okay, hello everyone. So in this video, we're gonna try to solve this problem about function. So we're given two functions, f and g, where the formula of f is this piecewise function, and g is this. Okay, so we have to find the inverse of f and the composition g circle f. So let's go ahead and start. Okay, once again, I have to apologize in advance if my writing might not look that pretty to read. You can contact me if you have confusion, perhaps. Okay, finding the F inverse. Okay, so I'm gonna write the answer according to Mr. Tantrawan's style, okay? Okay, first, because the F is a piecewise function, so we have to consider the values of x. So again, we must consider cases just like when we answer problems about inequalities. First, when the x is less than -1. Note that, note that y minus, oh, we set a new variable y to substitute the f. And the left side is just the formula for when this case happens. And from here, we want to find the explicit formula for x equals something. So let's go ahead and we got this. Then we got multiplied by, let me write the x in the left side. It means the same, yeah. Multiplied by -1. And here, x squared equals to something. That means the x itself equals to plus minus of the square root of this one here. But notice that this requirement here must met. So because the x is in that range, so we only take the negative solution. So let me write in the reasoning here. Because x is less than -1. That this notation here means because, okay? Okay, so we got an explicit formula for x. So this is the formula for f inverse. We just switch the variables into x, switch it back into x. But remember that we have to find the domain as well. So here we find the domain because x, we have this one here must be less than -1. And we just go ahead, multiply both sides by -1. That gives us square root of 1 minus y. The sign switched, okay, because we multiplied by a negative number. And because this expression have non-negative numbers on both sides, because square root of something are always non-negative, and this is just positive number, we can just squaring the both sides give us this, and we just got that gives us this, yeah. Subtracting both with 1, we get negative y greater than 0, and multiplied by -1, the sign switches. So we get this one here. So this, we gonna have to switch this condition back to the variable x in the later conclusion, but let's leave it there. Okay, for the second case is when the x sorry. Perhaps yeah, it's greater than or equal to -1. We have the formula for f we use is this one. So y equal to 2x plus 3. We want to find the explicit formula for x, so subtracting both sides with 3, then dividing both sides with 2, and I write the x in the left side. Doesn't change the meaning. Gives us this. So yeah, we got the explicit formula for x, so we just switch it x into variable x. And let me find the domain in the right side here, because x greater than or equal to 1, we must have the x value. Here we got it minus y minus 3 divided by 2 must be greater than or equal to -1. We just go ahead, simplify this, multiplying both sides by 2 gives us this, and adding both sides with 3 gives us this. So yeah, that's will be the domain for the second case. Sorry. Yeah. Okay. So the conclusion here will be the formula for F inverse is the one we got earlier. This one, negative x square root of 1 minus x when the x value is less than 0. And the second one is one here, when the x value is greater than or equal to 1. So we switch it back into x, not y anymore. Yeah. Okay, that concludes the first part of the problem. Now we want to find the composition. Finding G circle F. For composition of functions, so we just okay, so we just wait, what's wrong? Okay, the formula for G here, we can rewrite it as a piecewise function as well, yeah. So remember, when we have an absolute value, it becomes positive of the value when the number inside is non-negative. And it becomes negative when the value inside is negative. Or we can simplify this form into x plus 2 will be 3x minus 2 minus x plus 2x will be x. Yeah, and this we just add both sides by 2, and this one will add both sides by 2. So yeah, the definition for G can be rewritten as this. That means both f and g are piecewise function, right? So the composition for two piecewise function will be quite long, but let's do it slowly. Let me write this here. By we have we have G circle f of x is none other than G of f of x. Right. So we just plug in the value of f into the formula of G. So we can write it by, perhaps for answering this is better in an open space. Here we write we we plug in the value of f into G, so we just rewrite D is access into fx, which means we get this formula here and this. This apply when fx is less than 2. This apply when fx is greater than 2. So we can expand that form into, so now we plug in the fx's value. So we will get 4 definitions, right? First, we're gonna plug in this into the first. So let's so let me click this here so I don't forget. Okay, so we want to plug this formula into formula here. So we get 3 1 times 1 minus x squared minus 2, again 3 times the one below times 2x 3 minus 2. Next is plugging this into the one below here, gives us 1 minus x squared plus 2 and 2x plus 3 plus 2 plus 2. And for the requirement, the condition in the right here, we just rewrite this here when fx is equal to 2, and the fx formula we use is 1 minus x squared for this part. This must less than 2. But again, there's a second condition, that is we using this formula when the x is less than -1. So for the 3 remaining ones is the same logic. We use x less than 2, but we use the formula 2x plus 3 when the x is greater than equal to 1, -1. And this one will be similar, just switch the sign because we use this one here now. Same goes for this one. For the second condition, we just rewrite the ones here. Okay, so we will have to consider the cases here. So let's write a number line, draw a number line. For the first condition, we have Oh yeah, so we have to solve this first. We have 1 minus x squared, which is just 1 plus x, 1 minus x, right? 2, and this is none other than x plus 1, x minus 1. This sign switches, this becomes -2, right? Um, that makes some mistake. F, the F of the F is 1 here. So, okay, wait, there's mistake. Sorry. We simplify that one into x minus 1 greater than 2, and we further simplify it into x greater than 3, which means it will give us x greater than square root 3 and x less than negative square root of 3. Okay, so we just oh, it's an open circle, yeah. One circle of this one here. And this was must be met as well. So square root of 3 is around 1.7 if I'm not mistaken. So -1 should be here. And so we have the intersection. There is this region here. And first and the second one, let's paint it blue. The blue one is easy because just a linear form. Here we get 2x. Here we get 2x less than 1, -1, my bad, which gives us x less than -1/2, less than -1/2, say here, and it must meet the condition less than -1/2 is this one here, and greater than -1. Wait, -1 is here. My bad. This one here. So the intersection is this region here. Next, let's paint it in green. We already got the solution for this one earlier, but this one will be the solution. You can try it for yourself. The solution for this quadratic inequality will be negative. So basically with the same number as this one here, but because it has different sign, we just switch it into this one. Okay, so because it's here and here, but it's supposed to here. The one here is open circle, yeah. So the solution is here. And the last one, We gotta solve this one here. Let's use yellow since that's the only remaining color. We will have the same number as the one before, but in opposite direction. That means it will be negative a half. Negative a half here with the opposite direction there. And it must match as well here. Seems like I made mistake. But where? Oh, I found my mistake here. I made a mistake somewhere here. We multiplied both sides by -1, gives us x squared minus 1 greater than -2. Yeah, so that's just the mistake there. -2. So we add both sides with 1, gives us x squared greater than -1. And this one here, we have a square number bigger, greater than a negative number. Notice that this expression here always holds because any square number are always greater than a negative number. So this one here is just every real number. So I can write it like here, which means the one on the green one here. The only different for this third case is the sign. So the sign will switch into this, and there are no square numbers that is less than a negative number. So the solution here is nothing. There is no solution. So on the one here, automatically we don't have to use the formula there. And let's redo the red one. The red one means it's a real number that's less than -1. So it's just this region here because the first condition is just any real number. So there's no further condition. So that's it. We got this 3. Perhaps let me make it smaller. Resize it. The one in red should be the first one. The blue one is the next one. Then the yellow. Okay, so because the third case here doesn't have a solution, you can just ignore it. So the final formula will be just 3 definitions of, let's just simplify these forms. The first one will be -3x squared plus 3 -2. And second one will be 6x plus 9 minus 2. 9 minus 2 is 7. And we don't use the formula here because it has no solution for the condition. And the last one we use is this one. That's just 2x plus 5. 5. 5. Okay. And for the domains, we just write it just like the solution for each inequalities. So for this one is less than -1. For this one is in between, greater than equal to 1, but less than negative a half. And the last one is bigger than, greater than negative a half. I forgot. So that's it. And so we need to write the domain as well. So the domain is none other than the union of all these three. So it's just and the union of these three is none other than, you can rewrite it as just every real numbers, right? Because when we union this in this, it will give us from negative infinity into 1/2, negative 1/2, but the 1/2 is not included. But then 1/2 is included from here until every positive every greater number than negative a half. So like we can, you can imagine it as combining these three number lines, it will give us every real number, right? So the domain is just a set of every real number. So that's it for our problem about function. Thanks for watching this video. Okay, bye.